So, how is a lollipop and child, broken leg and doctor, dog and cat, and positive and negative charge related? In objective 1, we want to be able to represent organic compounds in different ways and then determine the shape, because shape will help us determine properties. So here are 3 ways to represent organic compounds. So this one is a Lewis structure. I'll put in the lone pairs on the oxygen. This is a skeletal structure, was a shortcut for a Lewis structure, and then this shows the wedges and dashes, which represents the shape at the tetrahedral carbon. Remember that a covalent bond forms when an unpaired electron from one atom combines with an unpaired electron from another atom. So a single bond consists of a bonding pair of electrons. Now, the valence electrons are the electrons responsible for bonding. So stop the video and answer this question. How many valence electrons are in each element? Remember that the number of valence electrons equals the group number. So the answer to each element is... Quantum theory describes the wave function of an electron in an atom. That's called an atomic orbital. Quantum theory also tells us the probability of finding an electron in a specific region of space. The shape of an s-atomic orbital, as shown in the hydrogen atom, tells us there's a high probability of finding an electron in that region of space. The shape of the p-atomic orbital, as represented by in carbon, tells us there's a very high probability of finding an electron in that region of space. So a bond forms when there's an overlap of atomic orbitals. So when 2 orbitals on the same axis overlap, that's called a sigma bond. When 2 orbitals on parallel axes on the same plane overlap, that's called a pi bond. So let's practice. Stop the video and look at the 2 pictures. Identify which bond is the sigma bond, which bond is the pi bond. So the answer is... So now that you can identify a sigma bond and a pi bond, which bond do you think is stronger? So stop the video and think about that for a few seconds. So the answer is a sigma bond, because the greater the overlap between orbitals, the stronger the bond. So remember, carbon has 4 valence electrons, so it can form single bonds, double bonds, and triple bonds. In a carbon-carbon single bond, there's 1 sigma bond and 0 pi bonds, but in a carbon-carbon double bond, there's 1 sigma bond and 1 pi bond. A carbon-carbon triple bond consists of 1 sigma bond and 2 pi bonds. So stop the video and draw in the pi bonds. So remember, there's 3 orientations in space for the p orbitals, the px, py, and pz. So the orbitals shown here are the px orbitals. So draw in the py and pz orbitals. So now you can show the overlap between the py orbitals and the pz orbitals. And we can identify the sigma bonds and the 2 pi bonds. Another important property is bond polarity, and we'll look at this. We look at how organic compounds react with each other. So stop the video and identify the polar bonds in this compound. Well, there's no HBr bond, so this cannot be an answer. The carbon-carbon bond is a nonpolar bond, so the CH bond is a slightly polar bond and the CBr bond is a polar bond. Now, what property of an atom tells us the atom with the partial positive charge and the atom with the partial negative charge? The answer is electronegativity. Electronegativity is the ability of an atom in a bond to attract electrons toward itself. So it's like a tug of war for electrons in the bond. The more electronegative atom will have the partial negative charge. The less electronegative atom will have the partial positive charge. So the more electronegative atom wins the tug of war. Electronegativity can tell us how a bond in an organic compound can react. So stop the video and you can answer these questions here. See an electronegativity table to help you out.